እንኳን ወደ ኢትዮ ዩኒቨርሲቲ ኤግዚት ኤግዛም ሶሉሽን ሀብ ዩቲዩብ ቻናል በሰላም መጣችሁ። በዚህ ቪዲዮ የሲቪል ኢንጂነሪንግ ሞዴል ኤግዛም በ23 ጁን ላይ ነበረውን የአስቱን ሶሉሽን ለሲቪል ምህንድስና ተማሪዎች የተሰራ ሶሉሽን ነው። ስለዚህ ይሄን ቪዲዮ ሲጀምሩ ላይክ አድርጋችሁ እንዲጀምሩ ለጓደኞቻችሁም ሼር እንድታደርጉ በቪዲዮቹ ላይ ኮሜንት እንድትጽፉና ለዩቲዩብ ቻናልን አዲስ ከሆናችሁ ቻናልን ሰብስክራይብ በማድረግ የቻናሌ ቤተሰብ እንድትሆኑ። ይሄ የመጀመሪያ ቴም ነው or thematic area 1 based on this structural engineering and ይህ ፓርት የቴም 1 ፓርት ነው። ቀጣይ በቴም 2 ቴም 3 ያለን አብረን እናያለን። የቴም 1 ፓርት የመጀመሪያ reinforced concrete 1 የሚል ኮርስ ነው። ከዛ ፖርሽን የወጣ ጥያቄ ነው። select the behavior of stress strain curve for low concrete grade. A, sharper at the peak of the curve. B, high failure strain. C, less failure strain. D, the behavior cannot be affected by the strength of the concrete. So the correct answer for the question is C. This is the correct answer. This is one of the behavior of stress strain curve for low concrete grade. Next, which of the following design philosophy uses factor of safety for materials and loads? A, working stress method. B, ultimate load method. C, limit state design method. D, working stress and ultimate load method. So the correct answer for this question is C, limit state design method. This design philosophy uses factor of safety for materials as well as loads. 3, RC beam with 250 mm width and 400 mm effective depth is provided with 8 mm by 2 leg strap at 150 mm spacing at a particular section. What will be the shear resistance at that particular section? So here we have constants, that is the shear capacity of the concrete, this much, and this the stress is this much. So A, 51 kilonewton, B, 28 kilonewton, C, 81 kilonewton, and D, 111 kilonewton. So the correct answer for this question is D, 111 kilonewton. Next, which type of beam is selected when the depth of the beam is limited by the architect? A, singly reinforced. B, T-beam. C, doubly reinforced. D, inverted L-beam. So the correct answer for this is this doubly reinforced type of beam is selected when the depth of the beam is limited by the architect. So C is the correct answer. Next, when moment redistribution at the interior support of the slab is done, the sum of distribution factor of all the member meeting at any joint is always A, 0, B, equal, C, less than 1, D, equal to 1. So the correct answer for this question is D. Usually this is the when the moment redistribution at the interior support of the slab is done, the sum of distribution factor of all the members meeting at any joint is always equals to 1. So D is the correct. Next, as per EBCS, which one of the following statements is not correct about the card element of positive reinforcement in a continuous member? A, minimum 2 bars should extend throughout. B, at least 1/3 bar should extend into the support of 3/4 development of the length. C, cutoff bars shall extend for a distance not less than effective depth of the member beyond theoretical cutoff point. D, cutoff bar shall extend for a distance not less than 12 times the bar diameter beyond theoretical cutoff point. So from this, which one is not correct? Therefore, the incorrect statement is the statement which is expressed as B is not, or B is the correct answer. The next from this part, it is reinforced concrete 2. This is the course name is reinforced course 2. The previous one is reinforced concrete 1. In this, it is reinforced concrete 2. The length between point of inflection of column is A, span length, B, face to face length, C, center to center length, D, effective backlink length. So the correct answer is D. The length between point of inflection of column is effective backlink length. Second order effect is considered for A, braced columns, B, slender columns, C, short columns, D, circular columns. So the correct answer for this question is slender column. This B is the correct answer. This the second order effect are considered in structural analysis to account for non-linear behavior of members under loading, particularly for structures subjected to significant axial load or moments. And this effect become more pronounced in slender column compared to these short columns. So this B is the correct one. Which of the following is not advantage of applying flat slabs? A, maximum depth, B, flexibility in design layout, C, increased speed of construction, D, flat soffit. Therefore, the correct answer is A. The use of flat slab in construction offers several advantages, including flexibility in design layout, increased speed of construction, and this flat soffit, which eliminate the need for false ceiling or cladding. And therefore, the option that is not an advantage of applying flat slab is A, maximum depth. So A is the correct answer for the question. Plastic hinges will not be formed at the point of A, maximum shear, B, support, C, under concentrated load, D, maximum bending moment. The correct answer is A. Plastic hinges will not be formed at the point of maximum shear. And here, plastic hinges in constructions form at location where yielding occurs, typically due to highest bending moment, and plastic hinges are region where the material undergoes significant plastic deformation, leading to redistribution of moments and force within the structure. Therefore, these plastic hinges are not typically formed at the point of maximum shear. Next, which one of the following is applicable when the shape of slab is irregular, there is presence of opening, and having varied support conditions? A, direct design method, B, strip method, C, equivalent frame method, D, yield line method. So the correct answer is D. Yield line method is applicable when shape of slab is irregular, there is presence of opening, and having varied support conditions. So the yield line method is a powerful technique used to analyze slabs by considering the formation of yield lines, which are hypothetical lines along with failure occur when the slab yields. And this method is especially useful for irregular slab, where other methods may not be as effective due to their complexity. So this is applicable. Okay, this is the courses steel and timber structure. Which one of the following is not the reason behind commonly using rolled steel I-section beams as beam? A, large moment of inertia with less cross-sectional area, B, large moment of resistance as compared to other sections, C, greater lateral stability, D, low mass to volume ratio. So these steel I-section beams are favored for beams primarily due to their large moment of inertia with less cross-sectional area at option A, which allows them to efficiently resist bending moment and support load with minimum material usage. And additionally, they offer large moment of resistance compared to other section types at option B, and greater lateral stability at option C also. So due to their symmetrical shape, and this mass to volume ratio is not typically the main consideration when selecting rolled steel I-section beams. instead of factors such as structural efficiency, load carrying capacity, and ease of application and installation are more significant in their widespread use. So this is D is the correct answer. Next, for structural collapse and structural component failure during design of steel structure, which limit state category is applied? A. Load factor method. B. Ultimate limit state. C. Permissibly stressed design method. D. Serviceability limit state. So the correct answer is B. Ultimate limit state. This during this for structural collapse and structural component failure during design of steel structure, this ultimate limit state is usually applied. Therefore, B is the correct answer, and this the ultimate limit state refer to the condition where the structure or its component reach the ultimate capacity of the material, leading to collapse or failure. And in the design of this steel structure, it is crucial to ensure that the structure can withstand the maximum load without experiencing collapse or structural failure. Therefore, the ultimate limit state is the primary consideration for addressing this scenario which is listed here. So this B is the correct answer. Next, the most economical selection for a column is A. Rectangular, B. Solid, round, C. Flat strip, D. Tubular section. So the correct answer is D. The most economic section for a column is tubular section. Okay, the most economical section for a column depend on various factors, including the load it need to carry, the material used, and the structural requirement of the project. And however, in many cases, tubular section at option D tend to be more economical for columns compared to other options like rectangular section, solid round section, and flat strip sections. So this D is the best answer from the listed one. Wave crippling generally occur at the point where A. Bending moment is maximum, B. Shearing force is minimum, C. Concentrated load act, D. Deflection is maximum. Therefore, the correct answer for this is C. Wave crippling generally occur at the point where concentrated loads act. The point of wave crippling occur at the location where the concentrated load act, and this is because the concentrated load causes the highest compressive stress in the wave load, leading to its local buckling. So this C is correct. Next, select the true statement about beam column member. A. They only resist flexural actions. B. Are inclined members. C. They only resist axial actions. D. They resist both flexural and axial actions. So the correct answer is D. These beam column members are structural elements that are subjected to both bending, that means flexural and axial load, and they may experience significant moment due to bending as well as axial force due to compression or tension. Therefore, they must be designed to resist both types of action simultaneously. So this is D is the correct answer. Next, strength of bolt is A. Minimum of shear strength and bearing capacity of bolt. B. Maximum of shear strength and bearing capacity of bolt. C. Shear strength of the bolt, and D. Bearing capacity of bolt. So the correct answer is this. The strength of bolt is minimum of shear strength and bearing capacity of the bolt. A is the correct answer. So the strength of the bolt is typically determined by the minimum of strength and bearing capacity, and this is because both shear and bearing failure mode need to be considered when evaluating the overall strength of the bolt connections. So due to this, A is the correct answer. Next, what design state must be considered to limit crack growth under repetitive load to prevent fracture during the design life of the bridge? A. Service limit state. B. Extreme event limit state. C. Fatigue and fracture limit state. D. Strength limit state. So the correct answer is C. This design state specifically addresses the effect of fatigue loading and the potential for fracture over the design life of the structure, and it involves analyzing the material's behavior under cyclic loading conditions and ensuring that the structure can withstand these repetitive loads without experiencing fatigue failure or crack propagation that could lead to the fracture. So this C is the correct answer. Next, which one of the following is not a requirement for bridge site selection? A reasonably straight approach load. B, minimum distribution influence of larger tributaries. C, permits parallel crossing as possible. D, well-defined banks. So the correct answer for this question is C. So while it may be advantageous to have the option for parallel crossing in certain situations, it's not typically a primary requirement for selecting a bridge site. So the other option is reasonably straight approach roads, that means at option A. Minimum distribution influence of larger tributaries at option B. And well-defined bank at option D are more commonly considered during the site selection process, as they directly impact the feasibility, safety, as well as cost effectiveness of this bridge project. So the one which is not a requirement for bridge site selection is permits parallel crossing as possible. Next, these are from fundamental of bridge design. For which load do you consider dynamic load allowance factor? A, design track. B, design lane load. C, pedestrian load. D, dead load of wearing surface. So the correct answer is A, this design track. Design track load are commonly associated with vehicular traffic, which can produce dynamic effect on bridge and structure due to vehicle movement. Therefore, considering the dynamic load allowance factor for design track load is crucial to ensure the structure integrity and safety of the bridge or the structure under dynamic loading conditions. So this A is the correct answer. Which is true about loading on bridge? A, wind load consideration is small and low bridge. B, add dynamic effect to pedestrian load. C, avoid dynamic effect to design track load. D, wind load consideration in longer span bridge. So the correct answer is D. The wind load consideration in longer span bridge is true about loading on bridge. So wind load consideration is particularly important for longer span bridge due to the increased susceptibility to wind-induced vibration and structural responses, and wind effect become more significant as the span lengths increase, and making it essential to account for wind loads in the design of longer span bridge to ensure their structural integrity and safety. So this D is the correct answer. Next, the governing action effect, which is observed only in box girder bridges. A, bending moment. B, torsion. C, shear force. D, axial force. So the correct answer is B. The governing action effect which is observed only in the box girder bridges, the torsion. And this box girder bridge, due to their box-like cross-section, are more susceptible to torsional effects compared to other type of bridge. And torsion refers to the twisting of the structure along its longitudinal axis, and box girder bridge are particularly prone to torsional effect due to their geometry. Therefore, torsion is a significant consideration in the design and analysis of box girder bridge. So this B is the correct answer. Next, what is the role of bearing in bridge structure? A, accommodate relative movement between superstructure and substructure. B, it is a wall constructed on both sides of the abutment to support it. C, is a communication route. D, retains lateral earth pressure. So from this, the function or the role of bearing in bridge structure is to accommodate relative movement between superstructure and substructure. So bridge bearing are structural components placed between the superstructure, that means the portion of the bridge that supports the traffic load, and the substructure, that means the portion that transfers the load to the ground, and they allow for the transfer of load and accommodate movement caused by factors such as temperature change, settlement, and seismic events, while ensuring stability and safety of the bridge structure. Therefore, A is the correct answer. Next, discourses from structural design part. Which of the following is not the behavior of beam cross-section having larger plastic moment and elastic moment ratio? A. Longer warming before collapse. B. High ductility. C. Greater deflection at collapse. D. Low ductility. The correct answer is D. Low ductility is not the behavior of beam cross-section having larger plastic moment and elastic moment ratio. So here, larger plastic moment and elastic moment ratio typically result in beam with higher ductility, not lower ductility. But the others are the behavior of this is the beam cross-section having a larger plastic moment and elastic moment ratio. Next, which statement is not true about strong band? A. It is an internal beam usually having the same depth as the remainder of the slab. B. Contains less concentration of reinforcement. C. It is a strip at unsupported edge. D. It acts as a support at the edge of opening. Therefore, the correct answer is B. The statement which is not true about the strong band is it contains less concentration of reinforcement. This is the incorrect statement. In reality, this strong band typically contains a higher concentration of reinforcement compared to the remainder of the slab, and it is designed to carry additional load and redistribute stresses, so it often requires more reinforcement to withstand these factors effectively. Therefore, this one is incorrect or not true about strong band. Next, which of the following factors doesn't influence earthquake resistance design? A. Geographical location of structure. B. Wind of location. C. Site soil. D. Strength of structure. So the correct answer is B. Wind of location is not it is not the factor, or it cannot influence earthquake resistance design. While wind can certainly be a consideration in the design of structure, it is not directly related to earthquake resistance design. And earthquake resistance design primarily considers factors such as the geographical location of the structure, site soil condition, and the strength of the structure to ensure that the structure can withstand seismic force and minimize damage during an earthquake event. So this B is the correct answer. Next, structure should be designed such that A. Minor and frequent earthquake can collapse the structure. B. Moderate earthquake can cause damage to the structure. C. Major earthquake should not cause any damage to the structure and the structure should be functional. D. Minor earthquake should not cause any damage to the structure and the structure should be functional. The correct answer is D. Usually, the structure should be designed such that minor earthquake should not cause any damage to the structure and the structure should be functional. So here, as per IS 1896, the following seismic philosophy is adopted. Here, 1. Minor and frequent earthquake should not cause any damage to the structure. 2. Moderate earthquake should not cause significant structural damage but could have some non-structural damage. That means the structure should become operational once the damage is repaired. And 3. Major and infrequent earthquake should not cause collapse. That means the structure will be dysfunctional for further use but will stand that people can be evacuated and property can be recovered. So these are the what the philosophies adopted. So from this point of view, the structure should be designed such that minor earthquake cannot cause any damage, so that the structure should be functional. Next, identify the correct wind load transferring system of a building. A. Truss, purlin, roof, girder. B. roof, truss, purlins, girder. C. Roof, purlins, truss, girder. D. Roof, girder, purlins, truss. So the correct answer is C. Roof, purlins, truss, and girder. So in this system, wind load are first transferred from the roof to the purlin, horizontally members that support the roof, and then to the truss, that means the framework of the beam forming the rigid structure, and finally to the girder, the large main or the main horizontal beam that support the truss and distributes load to the column or the walls. And this sequence ensures that wind load are efficiently transferred from the roof to the main structure element of the building, providing stability and structural integrity. So this C is the correct answer. Next, which of the following load combination is not possible? Dead load plus imposed load plus wind load, dead load plus imposed load plus earthquake load, dead load plus wind load plus earthquake load, dead load plus imposed load. So from this, the load combination which is impossible is the one which is expressed as C. Dead load plus wind load plus earthquake load is its impossible load combination. In most cases, earthquake load and wind load are considered separately in structural design because they represent different type of load and are often analyzed using different methods. And combining this load together in one load combination may lead to overly conservative or unrealistic design result. Therefore, option C is the correct answer. So this is the video that I have in this theme 1, and I will come with this thematic area 2 exit exam model questions from Addis Abeba Science and Technology University. And the next thematic area is highway engineering, and I will come with that video. And don't forget to liking the video, sharing and writing comments on the video, and becoming a member by subscribing my channel. Thank you for watching this.